Hi 7 and welcome to a series of videos for the topic of number theory. In this first lesson we're going to look at whole numbers. We're going to cover place value, writing numbers, ordering numbers, and then rounding. So where did our number system come from? It was actually invented by the Hindus in India in around about 100 AD, and then the Arabs carried this number system to Europe in 800 AD. And the reason that it was adopted is it had three main advantages over the other number systems of the time. Firstly, it had place value, which we're going to look at in a second. It had a symbol for 0, and thirdly, it was base 10. Previous number systems required that you wrote the same symbol over and over again, so it wasn't very efficient. But place value means the symbol just needs to be written in the right position, and you would be familiar with this. So here we have the place value units, the tens, hundreds, and we group them together in threes. We leave a little gap. Some people will put a comma there, that's okay. Then we have thousands, 10,000s, 100,000s, another gap or comma, and millions. So let's look at an example. For the number 1,678,320, state the place value of the digit 8. So let's have a look where it is. Now all we have to do is name that position, which is the thousands position. So that's the place value of the digit. What about the 3? Do you know it? It's hundreds. And the 6? This position here is 100,000s. Now every number can be written in terms of its place value, and we call this expanded notation. So if we want to write the number 23,789 in expanded notation, this is what we'd write. Looks a bit complicated, doesn't it? So this is the 10,000s position, so 2 times 10,000 plus 3 times 1,000 plus 7 times 100 plus 8 times 10 plus 9 times 1. So this is expanded notation, and we call this a basic numeral. Now if there's a 0 in one of the places, we don't write that place value. So for example, we've got 12,030,000. We're going to go 1 times 10 million plus 2 times a million, and then we're going to skip all of these and just do 3 times 10. Okay, let's go the other way. Write the following numbers as basic numerals. 2 times 100,000 plus 4 times 1,000 plus 9 times 10 plus 3 times 1. So what happens if I just write down the digits? I get the wrong answer, don't I? I mean, this is 2,493. We've got 2 times 100,000. So what's the problem here? We are missing a few place values. We have 0 10,000s and we have 0 100s. So instead what we need to do is this. 2 in the 100,000s position, 0 in the 10,000s position, 4 in the thousands. We have 0 hundreds, we have 9 tens, and then we have 3 ones. And there's our final answer, 204,093. Here's another one. We have 8 times a million. You can see we have 4 100,000s, we have no 10,000s, no thousands, we have 500s, no tens, and no units. So our answer is 8,400,500. And when we're writing large numbers, we need to be aware of the placeholder words like millions and thousands. So remember before I said we grouped the digits together in threes? At the end of each of those groups, we're going to use one of these placeholder words. So let's have a look at these two questions. We want to write the following numbers as basic numerals. We've got 6,407,000 and 6,407,000. So they're not the same number. So let's start with the first one. 6 million. We have no thousands in here, so we need 0, 0, 0, and then 407. What about the bottom one? 6 million. Now we do have thousands, can you see? 407,000 and nothing, so 0, 0, 0. Hopefully you can tell the difference between those two. Now you might be wondering, well, why do I need to know how to write numbers in words? Checks actually still require that. Here you can see in the picture a cheque for $9,885,697. You can see how it's written there in words. So you might like to draw up a cheque and put today's date, the amount, and sign it. And you can make the cheque out to your favourite charity. So I'm going to make it out to the RSPCA, and I've just put a random date in. And here's the amount in digits, or as a basic numeral. And now let's write it as words. 1,320,400. And I've signed it. Now we need to take notice of the place value of numbers when we put them in order. So for example, suppose we want to place these numbers in ascending order. Hopefully you remember that means from smallest to biggest. Let's have a look at these numbers. We've got 12,997, 120,876, 21,870, 2,980, and 1,230,980. All right, the smallest one is this one here, so it's going to go first. Now the second one, we've got two numbers that are in the 10,000s, and this is the smallest one, so it goes next. And followed by 21,870. And then finally we've got this one here, which is in the 100,000s, and then this one is the biggest. There we go. What word is used for ordering from biggest to smallest? Do you remember? It's descending. Now when we're comparing numbers, we use these two signs. This one is greater than, and this one looks a little bit like an L, is less than. So let's look at a simple example, 5 and 10. This is probably the way you learnt in primary school. The crocodile wants to eat the larger amount because it's a greedy crocodile. So we can see that the mouth is open towards the 10. So we say 5, this is less than, 5 is less than 10. How about this one? This time the crocodile is going to eat the 4 because it's the bigger amount. So we've got greater than. And we say 4 is greater than 2. So let's place less than or greater than in the box to make the number sentence true. Which number is bigger here? It's this one, isn't it? So we want the crocodile to open towards the 151,008. How about here? This one's way bigger. It says 12 million. So we want it open this way. And then finally, this one's a bit trickier. Can you tell which one is bigger? It's this one, isn't it? We've got 99,000 here as opposed to 91,000. So again, we want it open like that. Now, if numbers are large, we might decide to estimate them through rounding. And when we round, we use the following rule. We locate the digit that you're rounding to. Look at the next digit. If it is 5 or more, we round up. If it is less than 5, we round down. Here's an example. Round 134,679 to the nearest thousand. So you can see how I have highlighted the thousands position. So we look at the next digit. It's a 6. Because it's greater than 5, we round up. So that means this 4,679 is going to round up to 5,000. And we write approximately equal to, that's this symbol, 135,000. Let's try another one. We're going to round 134,215 to the nearest thousand again. So I have highlighted the relevant digit. There's the thousands position. Look at the next one. Now this time it's less than 5, so we're going to round down. Now that doesn't mean the 4 is going to go down to 3. This 4,215 is going to go down to 4,000. So it's approximately equal to 134,000. Let's try a couple more. 456,945, and we want to round these numbers to the nearest 100. So I have highlighted the hundreds position. Look at the next digit. It's a 4. So we're going to round down. So the 945 is going to round down to 900. So it's approximately equal to 456,900. All right, how about this one? This one's a tricky one. Again, we've got the hundreds position highlighted. Look at the next digit. It's a 9. We're going to round up. This 993 is going to round up to 1,000. And so we're going to end up with, do you know, 457,000. Okay, that's it for this lesson. In our next lesson, we're going to look at number operations.